Okay, MathBridge 1 students, we haven't really done a lot in the way of two-column proofs. I did one other one with you on video, and I'm going to do one here. And here we're going to actually prove the theorem we're working with in this lesson. It's the angle side triangle congruence theorem. And my objective is that you can use deductive reasoning patterns and a two-column proof structure to prove that angle side triangle congruence theorem. All right, so always in a proof, you need to look at the situation. They give you a situation. And here we have two triangles. You'll recognize them from the last video. And in this situation, we are given that angle A is congruent to angle D. And a good idea on these proofs is always to mark things like that. So I'm going to mark it in red, I think. Angle A congruent to angle D. And we're also given that angle B is congruent to angle E. I'll mark that in a different color. Those two in hot pink are congruent. And then finally, we're given that BC is congruent to EF. And if you watched the last video, you might have noticed that, and you might just notice anyway, that we can figure that out just by using the graph paper that's right here. That's really important to notice. That's called coordinate proof. And so you could actually prove these two triangles are congruent using what's called coordinate proof as well. But here we're going to do it assuming actually that the marks on the graph paper weren't even there. Okay, and that we couldn't just look at it and prove the two triangles are congruent. All right, and our goal is to prove that the triangle on the left, ABC, is congruent to triangle DEF. And what I want you to do, just for a moment, is look at this structure I've given you here. And I want you to think about it for just a moment. Maybe stop the video. See if you can fill this out on your own. Okay, and then we're going to go through it together. Right, hopefully it's apparent that, and I'll stick with this kind of magenta color here, just for fun. Hopefully it's apparent that the reason for statement number one is that all this stuff is given right here. So we just say given. Easy pie. Given. And maybe you know the reason why the measure of angle A plus the measure of angle B plus the measure of angle C, all the angles, all the interior angles at on the triangle at left are add up to 180, and that is the famous triangle sum. You should know this one. Triangle sum theorem. Okay, to review, we have the given information I've marked out, and we know that the angles in the triangle to the left add up to 180. Now the next statement here, number 3, says the measure of angle C equals 180 minus the measure of angle A minus the measure of angle B. How did we get to that? Well, we just subtracted measure of angle A and measure of angle B from both sides of the equation. And what allows us to do that, you may have written this down already if you did the proof in advance. If you didn't do the proof in advance, please try. You'll get more out of it. This is because we can do this because of the subtraction property of, whoops, I'm trying to write equal sign, equality. All right, so we have the measure of angle C is 180 degrees minus measure of A minus measure of B. By the same logic, I can just, and this is a bit of a cheat on the proof here, but I don't want to make a video that's too long. I'm going to say by analogous logic to number 2 and number 3 above, to this step and this step here, we can show that the measure of angle F right here, that one, is equal to 180 degrees minus the measure of D and E. Okay. The next step is given for you. It's just basically taking the information here, this information, and using the definition of congruent angles to say that the fact that they're marked congruent shows that their measures are the same. Sort of a technical step, but sometimes we have technical steps in proofs. Now here this gets interesting. And I want you to see that here we have this information at step 4. The measure of angle F equals 180 degrees minus D and minus E. Yeah? But we know from step 5 that A is the same as D, is equal to D, and B is equal to E, which is what allows us to come up with statement number 6 right here. And the reason for that is just substitution. We're substituting. We substituted A for D and B for E. So this is substitution. Okay. And now comes the fun part. Because for me, whenever I'm going to tell you that we're going to use our reason here is going to be the transitive property of equality. And whenever we're using the transitive property of equality, like I feel like I'm getting a good brain stretch, mental stretch. It's just really, there's something about that property that's really fun. Let's take a look at it here. So we know, let's go here and here. I'm going to use a kind of a different color for my highlighting. I'll use perhaps yellow, classic yellow highlighting. I want to go back to this statement. The measure of angle C, we're saying is equal to 180 degrees minus A minus B. And here, we know that the measure of angle F is also equal to 180 degrees minus A minus B. So, in other words, both C and F are equal to the same thing, and two items that are equal to the same thing are going to be equal to each other. That's what the transitive property of equality says. Very ancient idea here. And so we get here the measure of angle. There we go. Measure of angle C equals measure of angle F. Okay. Which shows us that ABC is congruent to DEF by, well, let's stop and take a look. Let's see what we have here. Okay. So right at the beginning, right, we knew we have these two angles, the angles marked in red here, A and D, they're congruent to each other. The two angles marked in pink, B and E, they're congruent to each other. And then this side, this not an included side, okay? And we can't use the angle side triangle congruence theorem yet because we need to prove it, yeah? But what we just did by a process of logical reasoning, I'm gonna erase this guy here, is we showed that, use a different color again, that C is congruent to F, right? And so I'll circle this here, this kind of part of the situation here, this situation here, and now we're in comfortable familiar territory, I hope, because you guys should know that this is an angle side angle situation. And so what we can do is we can say that the two triangles are congruent by something we already know. That's angle side angle, ASA, triangle congruence theorem. And we have achieved our goal. We have proved that triangle ABC is congruent to triangle DEF, thus proving the angle side triangle congruence theorem. To me, this is fun. I hope it's fun for you too.